The video shows solutions to some proportion problems. Watch and learn them here in Mathematics of Engineering. The first example requires for the fourth proportional to 5, 8, and 20. Recall that each element in a proportion is counted as a proportional. 5 is the first proportional, 8 is the second, 25 is the third proportional, and we are to determine the fourth proportional. This is easier solved using fraction form, which makes 5 over 8 is equal to 25 over x. So by cross multiplication, we get 5x as equal to 8 times 25. Divide both sides by 5 to get x, the fourth proportional, as 40. The second example looks for the third proportional to 36 and 48. Third proportional means there are only 3 numbers in the proportion, so it would be written as 36 is to 48, as 48 is to x. So there are still 4 elements, but only 3 different numbers. Writing this in fraction form, we have 36 over 48 as equal to 48 over x. Then by cross multiplication, the equation comes as 36x as equal to 48 times 48. So divide everything by 36 to isolate x, which is equal to 64. The next example states that if a is to b as equal to 1 is to 2, find the value of 2a plus 3b is to a plus 4b. Writing the two proportions in fraction form, there are a over b as equal to 1 over 2. Then the required will look as 2a plus 3b over a plus 4b. Because the premise has b as denominator, we divide the required ratio by b. So we get 2a plus 3b over b all over a plus 4b upon b. Next is to distribute the denominator b among the terms. So the numerator has 2a upon b plus 3b upon b. The denominator will have a over b plus 4b upon b. We plug in a over b as 1/2 and then simplify the rest of the fraction. So the numerator becomes 1 plus 3 and the denominator has 1/2 plus 4, which is simplified as 4 over 4.5. This is the proportion for the required, although it is still in a decimal form, which should not be. Thus, we multiply the fraction by 2. So 2a plus 3b over a plus 4b is equal to 8 over 9. This is the fraction form, and the proportion can also be written as 2a plus 3b is to a plus 4b, as 8 is to 9. Example 4 has the premise a is to b as b is to c. We are to determine a raised to 4 is to b raised to 4. Write the premise in fraction form and get a over b is equal to b over c. If we cross multiply the terms, we get b squared as ac. For the required, we can write it as a raised to 4 over b raised to 4. This can be written as a raised to 4 over the square of b squared. If we replace the denominator by the premise, we make a raised to 4 over the square of ac. Distribute the square in the denominator to have a raised to 4 over a squared times c squared, where we can cross out some of the a's. So the simplified proportion of a raised to 4 over b raised to 4 is a squared over c squared. This can be written in proportion form as a raised to 4 is to b raised to 4, as a squared is to c squared. The next problem asks for the number which should be added to the term ratio of 5:8 to make it equal to 1:2. Let's denote the number as a. So from the first term ratio, 5:8, we add a to both the numerator and the denominator, and it should be equal to 1:2. By cross multiplication, we get twice of 5 plus a, and this is equal to 1 times 8 plus a. Simplify it to have 10 plus 2a as equal to 8 plus a. Transpose variables and constants to have 2a minus a as equal to 8 minus 10, where a is equal to -2. For example 6, we are tasked to find the mean proportion of 27 and 3. By mean, we meant the number between. So the proportion becomes 27 is to x as x is to 3. In fraction form, we get 27 over x as equal to x over 3. Cross multiply and get x squared as equal to 3 times 27. Isolate x by taking the roots and have x as 9. Example 7 similar with example 6 with a little twist. It looks for a number added to each element to make them proportional. The elements are 10 over 7 as 25 is to 19. Denoting x as the required number, we add x in each numerator and denominator. By cross multiplication, we get 10 plus x times 19 plus x as equal to 7 plus x times 25 plus x. Expand the terms to get 10 times 19 plus 10x plus 19x and x squared. This is equal to 7 times 25 plus 7x plus 25x plus x squared. At this point, shorten the equation by canceling x squared. Then collect similar terms to get 190 plus 29x as equal to 175 plus 32x. Transpose terms to collect them and get 32x minus 29x as equal to 190 minus 175. This is simplified as 3x as 15. Isolate x by dividing both sides by 3 to get x as 5. Example 8 has g is to h as 5 is to 9, and the other proportion is h is to j as 6 is to 8. The task is to determine g is to h is to j. First is to write the proportions into their fraction form. So we have g over h as equal to 5 over 9. Then the other is h over j, which is equal to 6 over 8. In both proportions, one can see h as common, so we use it in identifying the equivalent connected proportion of the three terms. That is done by taking the least common multiple of the h values, 9 and 6. Their LCM is 18. So we are now ready to find the equivalent ratios. So first, g over h, originally 5 is to 9, is equivalent to g over 18. It is clearly seen that 9 is multiplied by 2 to make 18. So the same multiplier is required for the numerator, giving g as 5 times 2, or that is 10. The other ratio is originally h over j as 6 over 8, which will be adjusted to 18. 6 is multiplied by 3 to make 18. So the same with j, that's 8 times 3 giving 24. So g is to h is to j as 10 is to 18 is to 24. Example 9 is again similar with example 8. Given 4x is equal to 5y and also equal to 3z, determine x is to y is to z. From the premise, 4x is equal to 5y as equal to 3z. Analyze this with a ratio of 1. It takes 4 of x, 5 of y, and 3 of z to make 1. If we extract x is to y is to z, we take 1/4 is to 1/5 is to 1/3. To find the proportion, we should have a common denominator. So look for the LCM for 3, 4, and 5, which is 60. Next is to adjust the proportions. For x, we have 1/4 as equal to x over 60, where 4 is multiplied by 15. Next is 1/5 for y, converted into y over 60. That is multiplying the denominator by 12. Last is for z, which is 1/3 to make z over 60, where we multiply 3 by 20. So multiplying the numerators, we get x is to y is to z, which would turn into 15 is to 12 is to 20.